Welcome to today's video on Cambridge IGCSE Mathematics for the syllabus codes 0607 and 0580. Our topic for today will be trigonometry, where we will be looking at the subtopic right-angled trigonometry. Before we go ahead and look at our three trigonometric ratios, we're actually going to go ahead and see how we can label a right-angled triangle correctly. And this is something that we need to take particular attention to. So a right-angled triangle is a triangle which has one interior angle that equals to 90 degrees. So the triangle that we have over here is a right-angled triangle. Now, the hypotenuse that we have in a right-angled triangle is the side that's opposite to our right angle. So over here, this is my right angle. And the side that I have right opposite of it, that's this length AB, then this length is called the hypotenuse. An additional fact that you need to remember about the hypotenuse is that the hypotenuse is always going to be the longest side that we have in any right-angled triangle. The labeling of the other two sides that we have in our right-angled triangle is going to be dependent on a specific angle that we're considering. So in this case, we're going to consider the angle A here. So the side that I have opposite my angle is going to be known as the opposite side. So this is the angle here. The side that's opposite of it is the line CB. So this line CB is going to be known as the opposite side. The final label that we're going to give our right-angled triangle would be the adjacent side. So again, just like we did before, when we're dealing with the adjacent side, we also need to first consider the angle that we're looking at. So in this case, we're going to consider the angle A here, and the side that comes along with this angle A is going to be known as the adjacent side. So this is my angle A, the side that's next to this. That's the side AC is called the adjacent side. So there we go. That's how we label a right-angled triangle. Let's just go ahead and practice what we've learned so far. In this question here, we're going to be considering the angle A over here that's been marked theta. So if I consider this angle over here, then the side that I have opposite to this is going to be my opposite side. And the side that I have adjacent to it or next to the specific angle is going to be known as the adjacent. And then finally, I can see that this is where my right angle is. So the side that I have opposite to my right angle would always be known as the hypotenuse. So let's look at the next triangle that we have over here. Just like before, we can first go ahead and mark the hypotenuse. This is our 90-degree angle, so the side that we have opposite the 90 degrees should be the hypotenuse. So the side AB is our hypotenuse in this case. Then in this triangle, I can see that the specific angle that we've been given is this angle B here. So considering this angle B, the side that I have opposite of B is the side AC. So the side AC would be known as the opposite side, while the side BC over here would be known as the adjacent side. And that's how we would label a right-angled triangle. Next, we're going to move on to the trigonometric ratios. The ratios of the sides of a right-angled triangle are what's known as these trigonometric ratios. And for the IGCSEs, we're going to be focusing on three of these ratios. The first is the sine, the second is the cosine, and the third is the tangent. Now, for short, we can abbreviate them to be sine, cosine, so cosine would be cos, and tangent would be tan. So sine, cos, and tan. To work out what sine is, we're going to take the length of the opposite side and divide that by the hypotenuse. So sine theta would be the length of the opposite divided by the hypotenuse. Cos theta, on the other hand, would be the length of the adjacent side divided by the hypotenuse. And finally, tan theta would be the length of the opposite side divided by the adjacent side. And a mnemonic that we can use to remember these would be the mnemonic SOHCAHTOA. SOHCAHTOA helps us remember this because sine is equals to opposite over hypotenuse, cosine is equals to adjacent over hypotenuse, and tan is equals to opposite over adjacent, helping us remember the specific ratios. So over here, you can see that we're involving this angle over here, and to compute what sine theta is, what cosine theta is, or what tan theta is, we can get the help of our calculators to do that. Let's have a look at some exam-style questions on our trigonometric ratios. In this question, it's asking us to find the length of the side x. So x is this length that we have over here. Before I begin this question, the first thing I'm going to do is go ahead and label the sides of my triangle. So I can see that this side here is the hypotenuse. And with respect to the angle that they've given us, that's this angle that they've given us as 63, then the side BC is the adjacent side, and the side that we want to find out, that's x, is the opposite side. So we know the length of the adjacent, we know the size of this angle, and we need to find out the opposite side. Now, when dealing with a question like this, we're first going to figure out which of our trigonometric ratios have the adjacent as well as the opposite in it. And I can write the mnemonic up here. So the mnemonic that we know is SOHCAHTOA. And I can see tan is the ratio that we need because tan theta, like we've just looked at, is the opposite side divided by the adjacent. So we have been given the adjacent, and now we're going to work out what the opposite side is. So to work out what the opposite side is, we can do tan theta times the adjacent side, which would give us the length of the opposite side. And to work out the length of the opposite side, we can go ahead and substitute the values for tan theta. So we can substitute the angle here, and we can substitute the length of the adjacent side. This is going to turn out to be tan 63 times 7, which would give us the length of the opposite side. We can work this out using our calculators. So tan 63 times 7 would give us an answer of 13.74, correct to 2 decimal places. And this is going to be our answer. The second type of question that we can come across when dealing with our trigonometric ratios is instead of finding a length, we might be asked to find an angle. So let's look at this question over here to see how we can go about doing that. So the question here tells us, find the size of the angle x to 1 decimal place. So this is the angle x here. So just like before, I'm just going to go ahead and press label the sides of my triangle. I know this side is the hypotenuse, and with respect to my angle x, the side BC is now the opposite, and the side AB is the adjacent side. Once I've done that, I'll just have a look at these sides that we've been given. We've been given the adjacent and the opposite. So once we've figured out the sides that we have, or the known sides, we're going to figure out which ratio we're going to be using. So we have SOHCAHTOA, and I can see again we're going to be using tan because we have the opposite and the adjacent sides. So I'm going to write out what tan theta is. Tan theta is the opposite side divided by the adjacent side. And in this case, we need to work out what the value of theta would be. So tan theta would be 4 divided by 7. And this would give me the value for tan theta. But this does not solve for what the angle theta would be. And if we need to find out the angle theta, there's an additional step that we need to perform here. So to find out what theta is, I'll have to remove the tan from theta. And to do that, I would get the tan inverse. So I get the tan inverse of both sides of my equation. And this is going to be inverse tan on this side. So tan inverse over 7 would give me the answer for theta. And we can perform this on a calculator. Generally, if you look at this on a calculator, if you press Shift as well as your tan button, then that's going to give you tan inverse. So that's how we're going to work out what tan inverse is. So we're going to get the tan inverse of 4/7. And when we use a calculator to do this, we're going to get 29.74 to 2 decimal places. But the question wants us just to one decimal place. I'm just going to round this off. And the final answer would be 29.7 degrees. And that's the option 4 that we have over here. So there we go. That's how we solve questions with our trigonometric ratios. Thank you.